Hello and welcome back. Today we are doing discrete math and we are continuing part 3 of the introduction to logic. We're going to dive into tautologies and contradictions. So a tautology is a statement form that is always true regardless of the truth values of the individual statements substituted for its statement variables. And a statement whose form is a tautology, we can say it is a tautological statement and symbol, and this can be right at T. Okay, and this T to include all the truth values which are true. Okay, and a contradiction is a statement form that is always false regardless of the truth values of individual statements substituted for its statement variables. And a statement whose form is a contradiction is called a contradictory statement, and it can be written at C. And this C includes all the false values inside of it. So let's look at an example. Let's say we have only P, for example. We're gonna do a truth table to show if a statement form is either tautology or contradiction. Okay, so we have P, not P, P and not P, P or not P. Okay. Okay, so we have only 2 lines, right? So we have true, false. Okay, not P is just the flip of P, right? So false, true. Okay, so now we have P and not P. So P and not P is false. False and true is also false. Okay. P or not P, we have true or false is true, and false or true is true. Okay? So this column here, P and not P, it includes all false values, right? So we're gonna say it a contradiction because it contains false values. It's always false. Okay? And this column over here, P or not P, is always true. It includes all true values. So we're going to say it's a tautology. Let's look at an example that includes tautology, contradictions, and logical equivalence. So we're going to show that P and T, P in tautology, is logically equivalent to P, and P and C, contradiction, is logically equivalent to contradiction. Okay? So we have only one variable here. Remember, T and C are not variable. It's a statement. Okay? So only have we're gonna have 2 rows here. So we have P, T, P, and T, and then P, C, P, and C. Okay. Okay, and then we have 2 rows of truth values, which is true and false. Okay, we know that T is always true, right? So have true and true. Okay, so true and true is true. False and true is false. Okay, now we're gonna repeat it. P is true and false, and then C is false and false, since it's always false, right? Okay, so now P and C. So true and false is false. False and false is false. Okay, so I'm gonna name it our column P1, P2, P3, P4, P5, and P6. Okay, so the example asking show P and T is logically equivalent to P. So first we need to look at this. P1 and P3, okay? Do they have the same truth values to be logically equivalent to each other? They are, right? It's true, true, false, false. So we're gonna say since, I'm gonna let green. Since P1 and P3 have the same truth values, they are logically equivalent to each other. Okay, and the second statement, P and C is logically equivalent to C. So we're gonna look at P5 and P6. Okay, do they have the same truth values to be logically equivalent to each other? We have false and false, right? False and false. So yes, they are logically equivalent to each other. So we're gonna say since P5 and P6 have the same truth values, they are logically equivalent. All right, that is the point of tautologies and contradictions. Shall we look at another example? We should. Let's go. Next example we have is parenthesis P and not Q, and parenthesis not P or Q, tautology or contradiction. Okay, as always, let's construct our truth table first. We have two variables, so 4 rows of truth values, right? We're gonna have P, Q, not P, not Q, P and Q, P and not Q. Not P or Q, and then the whole thing, P and not Q and not P or Q. Okay, I'm just gonna leave it like this. Okay, so we have true, true, false, false, true, false, true, false. Not P is false, false, true, true. Not Q is just false, true, false, true. Okay, so we have P and not Q, right? So P and not Q. Okay, so true and false is false. True and true is true. False, false. False and true is also false. Okay? Not P or Q. So now we have or. So true or false, true, false or false, false, true, and then true. Okay, so now we look at this line, and this column and that column for the last column. So we have an and over here. So false and true is false, true and false is false, true, false and true is false, and false and true is also false. Okay, so the whole statement here have all the true values of false. By that, we can jump to the conclusion that this statement up here is a contradiction. Okay, so we're gonna write our conclusion since P, what's the problem? Okay, P and not Q, and P or Q values are all false. Then it is this statement is a contradiction. All right, that is our last example for this topic. See ya.